Hi everyone, welcome to our second tutorial on solving simultaneous equations. This time we're using substitution, but we're looking at the second part of that where we are solving two equations when they are in different forms. Last time we looked at two equations that were both in gradient intercept form. This time we're looking at two equations which are in different forms. One will be in gradient intercept form and the other will be in two intercept form. Let's look at this first example. You'll see here we have 3x plus 4y is equal to 29 and y is equal to 2x minus 1. You can see here that this first equation is in two intercept form and this second equation is in gradient intercept form. So what methods do we use to solve this pair of equations? The first thing that you need to do is to put the second equation into the first one in place of y. The original equation looks like this, and you can see y here in the first equation. What we need to do is we need to substitute the second equation into this equation and put it in the place where y is equal to that. The equation will now look like this. You'll remember the second equation was y is equal to 2x minus 1. So what we do is we put in 2x minus 1 in place of y here, because that is what y is equal to. So the equation becomes 3x plus 4y times 2x minus 1, and the whole thing is equal to 29. Now we expand the bracket. So our original bracket now looks like this, and when we expand it, our equation will look like this. 4 times 2x gives me 8x, and 4 times negative 1 gives me negative 4. So we now have 3x plus 8x minus 4 is equal to 29. Now we simply collect like terms. We have 3x plus 8x, and this will give us 11x. So our equation now says 11x minus 4 is equal to 29. Now we need to move the negative 4 to the other side of the equal sign. So the equation now says 11x minus 4 is equal to 29, and we move it to the other side. So the minus 4 comes over here, and when it moves from one side of the equals to the other, it becomes the inverse operation. It becomes plus 4. 29 plus 4 gives us 33, and 11x is equal to 33. Lastly, we divide both sides by 11. If 11x is equal to 33, 11x divided by 11 gives us 1x, and 33 divided by 11 gives us 3. So therefore, x is equal to 3. We now substitute x is equal to 3 into either one of the original equations to find y. I'm going to choose the second equation because it's the easiest one to use. Y is equal to 2x minus 1. Here is the x in the equation, and I'm going to substitute x is equal to 3 into this equation in place of x. So the equation becomes y is equal to 2 times 3 minus 1. 2 times 3 is equal to 6, and 6 minus 1 is equal to 5. So our solution to this pair of simultaneous equations is x is equal to 3 and y is equal to 5. If we tried the other equation, we should get exactly the same answer. The other equation was 3x plus 4y is equal to 29. This time I'm going to substitute x is equal to 3 into this equation here. So the equation will become 3 times 3 plus 4y is equal to 29. And 3 times 3 is equal to 9. So 9 plus 4y equals 29. And now I'm going to move the 9 to this side of the equals. It's positive 9 on this side, so when it comes to the other side, it will become minus 9. And that's what you can see here. 29 minus 9 gives us 20, and 4y is equal to 20. Now we need to divide both sides of the equality by 4. 4y divided by 4 gives us 1y, and 20 divided by 4 gives us 5. So once again, y is equal to 5. And we can see that the solution to this pair of equations is x is equal to 3, y is equal to 5. Thank you for listening. I hope this is useful and it helps you in solving simultaneous equations when the two equations are in different forms. I hope you find it useful.